Assalamualaikum warahmatullahi wabarakatuh. Today we will present our group presentation for CSC510. We choose question 2 for our project, which is properties of relation. Before that, let's introduce ourselves. First, my name is Siti Aisyah binti Idris as a programmer 2.
Hello, my name is Ahmad Sharmi Slamat and I'm as programmer in this project.
My name is Suan Darwisha binti Chewa Muhammad here and I am the project manager.
And my name is Nur Shahira binti Ihsan as system analyst.
And my name is Nur Izzatin Shira binti Zaharuddin as system designer. Here are the contents of our presentation. First, we will start with introduction, which covers study background and problem statement. Next is system demo, analysis of result, project limitation, and lastly, a conclusion. With this, let's get started.
I will start the presentation with background study. In a group work on the subject of CSC510 discrete structure, a total of 4 questions are provided and we can only choose one for this project. So the members of our team have agreed and decided to settle on question number 2, which focuses on the set and properties that include reflexive, symmetry, and transitive. The goal of our project is to create a program to determine whether the input of a relation set meets the reflexive, symmetry, and transitive properties criteria. The second goal is to be able to generate the reflexive closure, symmetric closure, and transitive closure for the set and also relation. For the program and software, we will be developing the program in C++ programming language with an application software called Dev C++. We also have chosen to implement non-GUI programs for the user interface. Next, problem statement, which is the first one, difficulty on how to identify which properties of relation should be used. Users sometimes have difficulty and problems to determine which relation should be applied on particular set given. And the second one is mistakes on resolving the relation of the given set. User is unclear and also confused the difference between reflexive, symmetry, and also transitive to answer the question. And the third one is a lot of time consuming for answering question manually. Users do not understand the function of each relation and causes them taking longer times to answer.
Okay, now I would like to demonstrate how our system works. So for the input, we use text file named as input.txt and set.txt. In set.txt, we need to put some element. For example, I will put 1, 2, and 3. Then click save. Next, for the input.txt, we need to put some relation, or we can call it pair of element. For your information, in this text file, there is no space between data set. So let's try use this input 1 1, 1 2, 2 1, 1 3, 2 2, and 2 3. Then we need to save this text file. Move on to the compiler. I will click run. Then it will display the result. So this is our result. Next presenter, there is Darwisha, who will explain more detail about this. Thank you.
After we have run the system, we obtain the output, which is not reflexive, not symmetric, and transitive. We can also get the respective relation closures. First, a relation R on a set A is called reflexive if AA is in relation R for every element of A in set A. Thus, relation R is not a reflexive relation because 1 1 and 2 2 is in relation R, but 3 3 is not in relation R. Next, a relation R on a set A is called symmetric if AB in relation R whenever BA in relation R for all AB in set A. Thus, R is not a symmetric relation because 1 1, 1 2, 2 1, and 2 2 is in relation R, but 1 3 and 2 3 is not in relation R. Next, a relation R on a set A is called transitive if whenever AB and BC in relation R, then AC in relation R for all A, B, and C in set A. Thus, relation R is transitive because the condition is satisfied. Next, to get the reflexive closure for relation R, we need to add 3 in relation R. R is a subset of S, and S is the reflexive closure of R. Next, to get the symmetric closure for relation R, we need to add 1 and 2 in relation R. R is a subset of S, and S is the symmetric closure of R. For transitive closure, we obtain the same elements as in relation R because the relation R is transitive.
Now we will talk about our project's limitation. Our system consists of 2 disadvantages. The first issue is unfriendly user interface. Due to our non-GUI design, a novice user may experience difficulty in navigating our system. They may have difficulty in recognizing our input field and to read the output. The next issue is inadequate knowledge. Since our system only process the set's relation properties and its closure, information on irreflexive, antisymmetric, and equivalence could not be obtained. This put a restriction on providing users with a greater understanding.
So for the conclusion, we know that by using the right type of property relation, we can get the expected result, which is why the process of determining the type of property relation is very important. This process can also be quite challenging because the relations are almost the same with one another. But by developing this system, it will solve the issue. In addition, we can also save our time on determining which properties are related. Moreover, a lot of people who are struggling with property relations could be helped by using this system. It could solve the problem quicker and shows the right answer. This system also one step further to develop a better mathematical environment, especially to those who are involved in this field. In the future, we also hope that we could develop even more functional systems to solve mathematical issues.